Okay, before I start my presentation, I want to ask if anybody knows F5, or I will ask the question different. Who in this room doesn't know F5 or what F5 has to offer or what we are doing? A few hands. I am a software developer from background. I have 15 years of software development experience, and I joined F5 Networks in the beginning of this year as a solution architect with a focus on DevOps and cloud native. And the first time I heard about F5 was around 3-4 years ago when I was doing a migration for a Belgian bank from a monolithic IBM mainframe application towards an OpenShift containerized microservice environment. And at that moment, we needed to interact our ingress routes on OpenShift with an F5 load balancer. So up until 3 years ago, I thought F5 was a load balancing company. And I want to play a small movie. It's only 2 minutes long to show that...
This is your incoming traffic. A massive superhighway.
Sorry. To show you that F5 is a lot more than just load balancing. And this is a great video that explains...
This is your incoming traffic. A massive superhighway headed for your application. Your application and its infrastructure serve all traffic. Your users. Good bots that enhance your user experience. Unwanted bots that add no value. And even worse, bad bots. There are many kinds of bad bots that cause trouble in different ways. From denial of service, to content scraping, to account takeover. These attacks affect nearly every industry. Not only that, bad bots, along with unwanted and benign bots, can skew your analytics, potentially providing bad data that influences business decisions. If bad bots reach your app, they can cause all kinds of problems. But if you make it hard to get in, you risk false positives that block the traffic you want. Why is it so hard to detect and block bad bots? Today's bots are more sophisticated. They behave more like humans. And they can evade traditional signature or IP detection. What's the solution? F5 Advanced WAF. It's a comprehensive solution that includes behavioral profiling and analysis. And it offers a full proxy architecture that enables visibility into each and every session throughout its duration. Here's how it works. The first line of defense consists of simple, challenge-free checks, signature matching, DNS checks, and browser capabilities, while allowing you to enable good bots that support your business. JavaScript challenges and continuous anomaly detection identify and stop malicious behavior. An advanced WAF's bot profiles feature lets you customize what action to take with different types of bots. Want to manage bots better? Head to f5.com/bots.
Okay, the reason that I show this video, because it explains in 1.5 minutes what F5 is all about. We are about securing applications from layer 4 all the way up until layer 7 in the OSI model. F5 is infrastructure, hardware, but also VM-based. We also have Dockerized solutions. But today is a talk about DevOps and a little bit on how Ansible fits into the whole DevOps schedule. And at the end, I will make the link again with infrastructure, automation, and F5. So I said I'm a developer, 15 years of experience, mainly with tools that I've written down here: Python, AWS, Java, Kubernetes, Docker. These are the things that I love to do. I also have some startup experience. Actually, how I learned AWS and Azure was in startups. Startups with not a lot of money, they typically go to the public cloud. They automate everything from day one, from infrastructure to infrastructure provisioning, all the way to develop CICD practices, which we will talk later. It is a 1-hour presentation, which I'm going to try to fit into 20 minutes, so I'm going to go fast and skip some slides, but I will try to make the essence pop out of the presentation. 3 of my favorite books: The Phoenix Project. I think I read it 7 years ago for the first time. I read it twice or 3 times in the meanwhile. It's a novel about an IT manager who becomes responsible for a brick-and-mortar store for the ICT department over there. And it gives you a very good idea on why people do DevOps and what are the fundamental things why you do DevOps and what does it help. DevOps Handbook is from the same writers as the Phoenix Project, and it's more into the practicalities of DevOps. It tells you what A/B testing is, canary deployments, etc. And last but not least is Epic Failures of DevSecOps. DevSecOps is an extension of DevOps where security team also starts to automate and integrate into the CI/CD pipeline. And in the bulk of my presentation, I will give you a few entry points on where you can do security automation within your CI/CD pipeline. Quickly go over the theory. What the Phoenix project learns you is that you need to look at your company as a manufacturing plant where your software goes from source code all the way until production, and in every stage something new is added, some quality checks are done, etc. So principle of flow is the first theoretical thing you learn from that book. The second is principle of feedback. If you look at your work as a continuous continuous stream of flow, it is very important that you have early on feedback. That means that you test a lot and that you want, if things go wrong, that you can fix them as soon as possible. If I started 15 years ago as a software development, it was typically release cycles of 3 months, and if you introduced a bug in the first week, 3 months later, who still knows what code he has been writing? So it's very difficult. That's why shorter feedback cycles and the principle of feedback is so important. The third one is more a soft skill, organizational element, and that's about continual learning and experimentation. When we go from dev and ops as being two separate things to DevOps, then there should no longer be a blame game culture, which is still in a lot of companies that I see between dev and ops, there tend to be a blame culture. So getting rid of that blame culture is very important. Value streams. This teaches you that you need to look at your software organization as the primary value stream of your company. Software is the new gold, is the new data. Data is the new gold, is the new oil, but how do you collect data and how do you present data to your customers? That's through applications. So applications are really the capital of your company. And I see a lot of people hiring an agile coach, but I tell people hire a pipeline architect who is responsible for the end, for the whole pipeline infrastructure, not just one team or silos, etc. Hire somebody who has an overview and who has the knowledge and the skills in the different departments that introduce CI/CD. Theory of constraints, and that's the last theoretical part, is whenever you look at your company as a workflow, then there will always be bottlenecks. A bottleneck can, for example, be a change advisory board, CAB, that comes together every month to decide on big network or infrastructure changes. And if you have a software development team which works agile, like 1 or 2 weeks development cycle, they cannot wait on that one monthly meeting. So it doesn't have to be a technical bottleneck, but the point here is that if you optimize upstream of your bottlenecks will become worse. So always tackle your bottlenecks first. And from my personal experience, for the last 15 years, software developers have been the target of optimization. We have to work in smaller sprints, we have to do agile. I would say the next step is to also work agile and to automate your infrastructure provisioning, because that's de facto the standard in a lot of companies, is de facto the new bottleneck today. Some elements in the market that drive DevOps are agile flavors. I'm going to skip this one. Move to the cloud. Software developers love and embrace the public cloud, although reality is that not all companies just go to the public cloud. Still many people have private data centers. Operational teams sometimes fear the cloud. My message here is to operational teams: don't fear the cloud, but learn from the self-service capabilities. Companies don't go to the cloud because it's a cost optimization. They go to the cloud because they can be agile. Software developers can spin up their own databases and queues by a click of a button or by automating it using Ansible, for example. And then the last trend, which I said about the bank, they're moving from big monolithic applications, for example, to microservice architecture. And if you go to a microservice architecture, you have many more moving parts, many more moving deployments, which means that having your infrastructure automation in place is very key. So that's enough theory and market trends. The first thing when you start CICD is to use a CICD Orchestrator. Most of you will know most of the brands here. Jenkins, GitLab, Bamboo are very famous. And then also you see that the public cloud offers CICD as a service. From the moment you have picked your CICD Orchestrator, and this is pure out of experience, I see many people focusing on you should have one pipeline and everything should go from source code all the way to production seamlessly, fully automated. I think that's a nice dream and that can be an end goal, but in reality I'm a more pragmatic person. I would say start by splitting CI and CD, and I will later explain why. The CI part, continuous integration, the CD part, continuous deployment and continuous delivery. Quickly going over to all the stages. The first stage is development. Software developers write code in Eclipse, IntelliJ, Visual Studio Code. They do their software configuration management. They store their source code. They version it. There is branching. Git is the de facto standard, I would say there. Code scanning. And this is the first link to DevSecOps. So after you have your source code in source control, you're typically going to use tools like Upscan, BlackDuck, WhiteSource to do static application security testing, SAST. And that's the first link with DevSecOps. DevSecOps is the integration of software automation, of security scanning tools into your CI/CD pipeline. SonarCube can do more than only security checks. It also checks for license violations. So if you have dependencies, you might not want to have GNU VPL v3 in your dependencies, because then it means that you also need to open source your own source code. So for many big companies, license violations is a nightmare. So hence these tools, in this stage you check for those. After you scan your code, you're typically going to build it. I'm a Java Python guy, so obviously Maven, Gradle in the Android world, SBT in the Scala world, Webpack, NPM, not really build tools, but let's say repackaging tool or obfuscators or minimizers, doesn't matter. You transform your source code in the JavaScript world, and then Apache Ant is an old one, also used in the Java world. So then you've built your software, and then the next step is typically you're going to unit test it. And in my world, in Java, for example, you use JUnit to write unit tests. If you're developing microservices, chances are very high that you're using REST APIs. So there is an open API initiative that standardizes on how REST API should be defined. Swagger is the tooling set. Postman is a great tool to do REST automation. You can automatically script your REST calls there, so you can really write tests in Postman. And then Rest Assured is a framework to do unit testing as well. And then the last part of the continuous integration part is to have your source code, which you tested on a unit level, is to package it, to bake it in stone, to make it a binary deliverable, which will not change anymore in the second pipeline, the blue pipeline. There, these days, Docker, especially in containerized environments, is the winner. Of course, still people are using VM. It can be an RPM. Does it have to be a Docker file? The thing is, it's a binary deployable, which you typically store in a Docker registry, for example, but also Nexus and Artifactory, who were the old guys for storing binary artifacts, also have included Docker registry support into their platform. Packer is a great tool from HashiCorp to transform binary deployments. So now I finished the green pipeline. In this pipeline, you want to give your software developers as much as freedom as possible. In a bank, because people are using different software programming languages, probably, if you're going polyglot, microservice-based. And in the second pipeline, that's about deployment. Deployment, that means that we are going to deploy in the first step, for example, our application into a test environment for later on to do some testing. Next slide. So then we enter the realm of Ansible, SaltStack, Chef, Terraform, Helm, Bolt, and Puppet. This is an Ansible meeting, but Ansible is the de facto standard these days. It used to be Puppet and Chef, but Ansible, I think this year or last year, surpassed the leadership, let's say. They are now the leader in the space. Bolt is the answer of Puppet. So Ansible is agentless. Bolt is their answer, but Bolt is only a few months old, and I didn't play with it, but that's the answer of Puppet. Terraform, more in the area of infrastructure automation. Ansible, you can do infrastructure automation, don't get me wrong, but there is a little bit of overlap between the tools, but they also have their primary strengths and some of their weaknesses. But since it's a talk about Ansible, I'm not going to make those comparisons right here on stage. That's not necessary. That's not my point I want to make. Next step is, so you deployed it into a test environment, then you're typically going to do some testing. That can be performance testing, that can be integration testing, user acceptance testing, and security testing. And this is the second link towards the DevSecOps story that I in the beginning mentioned. Here is where you're going to do your dynamic application security testing or your interactive application security testing. So your DAST or EAST. Then we are playing in the area of tools like Qualys, Nessus, Vulnerability Scanner, OWASP, SAP, Selenium to do automated browser interaction, JMeter to do performance testing. Okay, halfway. And then the last part, so we tested it, now we're going to release it, and this is a step that many companies skip, or many people standardize on Jenkins and they want to do everything in Jenkins, or they standardize on Bamboo and they want to do everything on Bamboo. Gartner calls these ARA tools, these are application release automation tools, and there is a very good reason why I think they are important. What those tools, I am a big fan of using the right tool for the right job, and I don't believe in silver bullets. So here, I think these kind of tools, if you do not know them, they are definitely worth looking at. I would say Xabialab, Deploy, and IBM are a bit old school. I'm not trying to be denigrating, but they are older, and Spinnaker is the new kid in town, which started as a Kubernetes deployment tool, but also has now official OpenShift support. Octopus Deploy is typically used in the Microsoft world. Why are these tools important? Because they allow you to do A/B and blue-green deployments. So for those, or canary deployments, for those who don't know what the A/B, blue-green, and canary deployments are, there is a little bit of a nuance difference, but it always boils down to the same. You have a certain version of your application running in production, for example, V1, and you want your software development team just developed for 2 weeks in their sprint, and they have a new version, let's say V2. In order to push it to production in a, let's say, responsible, in a safe, damage controlling way, what typically happens is that rolling updates-wise, you're going to deploy the second version next to the old version, and then you're going to use load balancing techniques to direct traffic in the beginning 10% to the new service, and let's say 90% still to the old version of the service, in order to minimize the blast radius. So if something really goes wrong, the 10%, only 10% of your end customers would have been affected, and you can roll back your change and fix it and then go to another canary release deployment. If things go well, you're gradually going to move from, let's say, 90% to the old and 10% to the new. You're gradually going to shift to 50-50, and in the end, 100% to the new version, and you can dephase or undeploy the old version. And these tools really are built for these kind of things. Another thing, and that's a little bit my background with the banking history, that's auditing. Auditors will ask you on a given day when they come to do their audit, do you know what kind of software you have running in production today, and what kind of version of products you have running in production? And this is not an easy answer. And if you use Jenkins, okay, you can get that metadata probably out of Jenkins somehow, but it's not convenient. It's not made for that. Jenkins is a CI tool. These tools allow you to give you a single pane of glass, and you have an overview of everything that's running in production, not only today, but also 3 months ago. 3 months ago, you got breached. What was running in production? You can answer your auditor these questions. And last but not least is that you have rollback options. And this is a little bit tricky. If things blow up in production, and your operational guy who has a beeper Saturday night, 11 o'clock in the evening, he doesn't have the chance, or it is unrealistic to think that he will go through all of these phases. If the house is on fire, it needs to get fixed as soon as possible. So these tools allow you to roll back, just go to the previous, hopefully more stable version. All things you can probably also do in Jenkins, don't get me wrong, but these tools are specialized in that. And that's why when I go back, the next step is to publish it to production. And I didn't talk about infrastructure changes yet, and that's Ansible and infrastructure automation. That's what this talk is really about, but I wanted to give you the overview. So let's go to the infrastructure automation part. I look at infrastructure, the first thing that is important is infrastructure as code and having a single source of truth. Just like your software developers have their single source of truth with regard to their source code, also the configuration of your network, of your infrastructure, instead of, should be in source control. The old days, it's a bit pet versus kettle and snowflakes. Snowflakes is where every server had a special configuration, and somebody logged in with SSH and did some commands, and if things blew up, nobody could ever reproduce that Snowflake server. So that's why the trend in the industry is to make sure that all your configuration is stored in source control, so that you can always rebuild from scratch, and more important, that you can revision everything. So, and there are two approaches to infrastructure as code, and that's how REST APIs and infrastructure is working together. One of them is the imperative API, or the imperative way of configuring your devices. The second part is the declarative way. So what is the difference between imperative and declarative? In an imperative way, you need to know the order of execution of certain commands. For example, on a big IQ, a product of F5, you need to, if you want to expose a virtual IP, then you have members and pool members, you need to configure those things in a certain order or in a certain sequence, because if you do not, there are dependencies between one step and another. So this requires a specific domain knowledge of that infrastructure as well. So I'm not saying that imperative APIs are bad, by the way. I'm just pointing out that they are more difficult to understand for people who are not expert in that infrastructure area. And look at me, I'm a software developer. I cannot have knowledge of all the 5, 6 different hardware vendors and infrastructures that are out there. That's why the popularity of declarative APIs, and as opposed to imperative APIs, in a declarative API, you just ask your end result. This is what I want, and you figure out in the back on how to deal with this. And this is basically the cornerstone of OpenShift and Kubernetes as well. Kubernetes and OpenShift are pretty complex with regards to software-defined networking, etc., and routing and network policies, all these things. You don't need to care how this works underneath. No, you just give an end result, YAML deployment files, and this is what I want. So in OpenShift and Kubernetes terms, one speaks of we go from actual state to desired state, and there is a convergence between those, and that's big. And that's the same, so that's the whole concept of declarative APIs. They require less domain knowledge of the product. Now, this is an Ansible slide. If we look at the Ansible landscape, I think 1 or 2 months ago, Ansible or Red Hat or IBM, whatever, published a paper on the different Ansible modules in the network and security hardware vendor space and software vendor, because most of them, they're not only hardware, but also software-based solutions. And this slide I used to go to talk to NetOps and SecOps people to say, look, you no longer have an excuse to keep everything configured through GUIs. You can automate it. I'm not saying that 100% of all infrastructures can be automated. I'm not naive, and I'm also not a fundamentalist. But start with the low-hanging fruit. Start with the bottlenecks. And look, all the vendors out there in the space, including F5 Networks, my employer, support imperative APIs. F5 goes a step further with declarative APIs, but that's the next slide. So no more excuses. Ansible is out there. The whole infrastructure world, including all public clouds, all embrace Ansible. There are more than enough modules to serve your needs. Now, how does F5 fit into this picture? So I told you that we have imperative APIs, but we also have declarative APIs. We follow thereby the foundations of OpenShift and Kubernetes to make infrastructure accessible towards software developers. And we do that by, we basically have 3 modules. Declarative onboarding, which is basically how you initialize your F5 products into the network. They need some licensing, they need some management IPs, etc. That's typically declarative onboarding. Then you have application services 3, which is AS3, and that's basically made for software developers who are typically responsible for one application or several microservices, and it's a declarative way in a JSON format with Visual Studio Code linter plugin. So we have a Visual Studio Code plugin that allows you to verify the JSON schema of your AS3 declarations, but basically it is configuring on top of that F5 device, which is at the beginning completely application agnostic. You start deploying applications, and then you're going to put F5 security, like for example the movie that I showed, you're going to add WAF, bot protection, advanced WAF, these kind of things. So these are typically done in application services 3. The fact that F5 made the choice to standardize on JSON makes us compatible with all the players on the market. So you might use Ansible already for other infrastructure changes. Ansible has a URI module which allows you to post JSON files, so this allows us to have Ansible support in a convenient way. Terraform, Bolt, SaltStack, even if you do it straight from your Jenkins pipeline files, you could also do it just with a curl or a wget, it doesn't matter. And then a little bit on how I look at infrastructure changes. And for people that work in the public cloud and only work in the public cloud, this might sound a bit weird, but you need to realize that there are also still many companies that have private data centers or maybe hybrid multi-cloud approaches. So I see 2 types of infrastructure changes, one-off changes and changes that go along with the life cycle of your application. Typical one-off changes are a database. You only need to provision a database once. You may do data You may do database schema changes, but these are then the second part of changes, things that evolve with your application. Another one is, for example, REST API protections of your new API endpoints. That's something that changes continuously with your software lifecycle management. And how I fit them into the pipelines is, remember, pipeline 2 was all about promoting builds from test to staging to production. Your infrastructure changes that go hand in hand with your application belong on the same place where you do your build promotions. And for one-off changes, a very popular product is ServiceNow. And with ServiceNow, you basically have a self-serving platform where developers can ask for a database, where they can ask for an opening of a firewall port. You have your Ansible Tower product, which is, of course, Ansible modules. They are stored in Git. And then you can use Ansible Tower to push configuration, and these are two F5 products, BigIQ and BigIP, to do your layer 4 and layer 7 protection of your applications. I think I am on 22 minutes, so I think this is the last slide. This is a little bit to end. So our CEO, Francois of F5, talks about application capital. Applications are the most important and most valuable asset of companies these days. Data is the new gold, or in this case oil, because these are old pipelines, and applications are those that deliver the data but also gather the data. Your pumps are your software developers who are writing that source code, and your pipelines are your CICD pipelines backed by Ansible. The whole slide deck was a lot of tools, but Ansible is a very important cornerstone to bridge that gap between development and operations. And then the oil goes to the customer, and the customer is happy, and we all earn a living. That's more or less, in a nutshell, 23 minutes for a 1-hour presentation. So.